Hi everyone, thank you for being here. So this session, as you know, is about agentic and agents that actually work, not just demo, but real systems that plan, act, and use tools. We have three guests to see this from a very different angle. So first, Benjamin, who is building soaring agents that run inside organization where reliability really matters. We have Robert, who is developing agents that work on huge code base, so especially for developers. And we also have Ramin, who is building the chips that are needed to make agents run. The goal of today is simple. We are here to understand where agents bring values, where they fail, where they fall, and what they change the way we build and work. My first question for you guys is, where do you see the most value in agentic today? Benjamin, if you want to start.
Thanks, Frederic. Well, the most interesting thing about is artificial intelligence approach that you make an autonomous system who can interact with your different agents or your tools, and that brings you a lot of opportunity to resolve some issue if you install it in the right way. So, but I think we'll talk it after about that.
Ramin?
Obviously, in coding today, they're simple agents, but they're very powerful. But we also have partners and customers who use agentic AI for safety on, like, for example, oil rigs in medical to monitor patients with different sensors and different possibilities of action. And in education as well, to specialize for the attention span and the knowledge and the speed of specific kids. We see those agentic systems starting today.
Yeah, definitely in our case, at Blackbox, we see a massive impact for developers in the coding use case. And coding is very broad, so you can be someone who's just starting out, you can be someone who is very professional, at a very large organization, being responsible at very complex systems. So the coding space is extremely large, so it doesn't just cover one aspect of it. One thing we like to see the impact of agentic AI on coding specifically, something that we see on a day-to-day basis in San Francisco, the adoption and how widespread. You see way more cars going on in streets today. You have no driver in the seat. The ideal goal where agentic AI can be for coding is that it can have such an impact in cars cases. These are like real people. You can have impact on lives. Being secure is very important there. And on code, you can have big impact, making sure that whenever agents are deployed, they are still secure as was mentioned right now, and they can also perform very high level of engineering on tasks that are being executed.
Yeah, because in the end, these agents are interacting with human. So I think it's very important to have also a human in the loop and also to take care of the user experience. Do you have any take on that, and how important is that for you?
Okay. Well, for that, we can take an example, for a use case example. For example, one of my favorite use cases was when we did a transcription service for law firms. You can imagine, you have an investigator and lawyers working together doing interview for internal investigation for companies. And at the end, they needed a transcription service secure and compliant. And when you made it, you have a big question. At the end of the treatment, you have a legal records, and you cannot have a mistake on it. It's not possible. But everyone, I think, in this room know that 100% of accuracy for artificial intelligence doesn't exist. So at this moment, we start to thinking about the capacity to give to the users to monitor all treatment of the artificial intelligence. That's why at the end of the treatment, you are sure that your legal records is under 100% perfect.
Definitely in the short term and medium term, you're going to have human in the loops. I mean, whether, for the example I gave for security in a construction site or medical or education, or even coding, eventually the advice is given to a human who will take the important decisions. Even in coding today, if you use an agentic workflow, if it wants to go for a specific implementation, it's going to ask your okay before doing it, with the caveat that long term, when we reach and pass human intelligence, maybe there's going to be less and less human in the loop.
Yeah, and for you, Robert, so since you run a black box AI, which is a code agent, how do you know what action the human should be asked for, or what the agent can do autonomously?
So what we provide the user full control on is that we give them access to decide. They can choose a mode that is completely autonomous, and the levels of autonomy we're getting close to are really exciting today. Like one of the recent releases we did that makes a big difference in the way engineers are really working on their code base today. We deployed something called full self-coding. So this is the very first version that is available today that is out in the public. It's not private beta. So what this means is that because we've been seeing the performance so high and with very high reliability that on what the tasks are being executed, this is the most complete autonomy that we've released and we've seen today available. What this means is that basically any company today, they have a running server right now in production that is responding to user requests. So what we've gave access to this agent is we've given them access to the running server logs in real time, which is a very complex task because typically you have system engineers that are just monitoring these things and just catching any error that can occur. So what the agent is doing right now is able to have access to real-time server logs, whether there are like critical warnings, just benign alerts that are just showing up, but it's able to understand this context of what's currently running in production. It's able to have access to the code base that is assigned to the server right now, and it has the context to go ahead, do the implementation of a solution of any currently running error, and it can finish a pull request that the engineer can, at this point, decide to have even the autonomy to merge this pull request by the agent.
Okay.
Because it ran the test, it just did everything. It has the environment variables, it has the test accounts, it has everything that's required. So the engineer can decide to give it access to even merge it into the main branch where it can kick off another deployment. And it can also do another series of testing on the new version that has just been released, decide to roll back, to revert, and do these decisions. So if the engineer decides they have this ability to do a full self-coding mode where they can really have more confidence, we're seeing a lot of adoption going in this direction because like what we're really noticing is that these agents, definitely people like strong engineers are still required for supervision, for monitoring, but the level of testing and iteration and self-correction that is available now on these agents is surpassing what an engineer is able to do, the iteration cycle. So this is one of the exciting things that we just released recently.
Impressive. My next question is about, since agentic is still very new, there's still a lot of unsolved engineering problem. And I was wondering for you guys, what do you see as the hardest unsolved problem we have right now regarding agentic? This is a hard one.
I think it's got to be related to the physical world.
Okay.
If you have a use case like in the hospital or in the field where you have cameras, maybe drones monitoring situations and people. So there are multiple steps, right? They have to perceive the world, and that could be video, sound, other things. They have to reason about what's going on real time. Then they have to, once they reason, then they see they need to do something, they have to plan on how to do it. Then they have to do it, they have to execute. And then if something goes wrong, they have to learn, right? Not to redo the same mistakes. So in the physical world, as Yann Lequin was saying, it's much, much harder than doing it with written text.
Yeah.
So yeah, I think doing real-world deployments is going to be very valuable, but very challenging.
Yeah, you're true, and I think you have another issue, but more European for Europeans. It's about the simplicity to deploy a sovereign or compliant ecosystem of agents. In the developers' world or buyer world in Europe, the sovereignty have a lack of reputation in general. We think that it's less performant, less easy to use, and I think it's just a mistake. You don't have to compromise between sovereignty and performance. It's really different, and we need to work on it too for integrate a new type of project, for example, medical. It's really important to be compliant.
And you, what's your toughest problem?
Yeah, definitely. In our case, like definitely on these points, we see it apply as well. And in other cases, we also see it like two primary that come to mind is that definitely on the security level. So whenever you're giving them a lot of autonomy, you want to make sure that they're executing with very high security standards. That's one area. So whatever is being developed as code is not something that might lead to some other problems. So that's on one front. The other front is that we're now at more than 30 million users, growing at 1 new user per second right now at a pretty similar rate of GitHub. But one of the things that we're really noticing is that the one key problem, which is not necessarily directly easily solved by technology today, is that the ability for users to really extract the full value of these agents. The amount of value that a user is able to extract from it is as much as they're able to prompt it, able to ask them to do more complex tasks, and also when the user is maybe not to the level of the agent is able to perform a task, having the user review it wouldn't make so much sense. So maybe the agent did a very successful execution, but is in the hands of the wrong user, so they wouldn't really be able to judge whether this was good or bad. So the piece of making sure that users are able to extract the full value, even though they wouldn't be fully equipped to assess its performance, that's also another component in it.
Yeah, what you said is really true, because in general, what we saw this year, it was a lot of company or teams, project teams in artificial intelligence, thinking about the technology, but the real thing is to be totally user-centric, to give the value. And we saw a lot of projects fall just because of that.
Yep.
Raman, the next one is for you, because you mentioned just our physical environments, and we all know that AI not only live in the cloud right now, but also in our device, on drone, or even on car. Could you say a word about what is hybrid AI?
Yeah, I mean, I think people know by now that AMD makes GPUs for the data center, but what a lot of people don't know is that we actually have chips running in embedded devices like cars, satellites in space, airplanes. The rover on Mars is also powered by an AMD chip. Those chips really come from the acquisition of a company called Xilinx. That was a $50 billion acquisition, the biggest in semiconductor history. But they make FPGAs, so chips that are programmable at the hardware level in the field. They can reprogram, and they have embedded processors, they have AI accelerators, and they have the programmable hardware fabric. So Subaru uses that. For example, if you're using Subaru, the EyeSight front camera has an AMD chip in it. And obviously, it's a super low latency AI chip. If a kid jumps in the middle of the road, it's not going to go and ask a data center GPU what to do. It processes it right there and breaks.
No connections there.
Right, exactly. And again, we have a similar chip on Mars. We have chips like that. So I said part of what the agent does in the field is perception. And those chips have a lot of different type of sensors. The IOs are programmable. So they're also used in the CERN, where you accelerate protons at really high speed, and they collide and generate millions of particles that decay extremely rapidly. So those chips actually analyze the results of the collision and analyze them in nanoseconds. It's like super rapidly right there. It never goes to a data center. So those chips are deployed pretty much everywhere on Earth, in space, on Mars, and the hybrid computing consists on doing the low latency compute on the chip and the high reasoning or planning that's not necessarily latency sensitive in the cloud. So that's the hybrid computing platform we're creating.
Okay, yeah, I think at some point you also have to send the data back to retrain your model because you cannot train locally.
Right, right.
Send it back.
Yeah, I guess you could maybe train on edge GPUs, okay, on local workstations, but yeah, so training would be at the edge and in the cloud for the retraining. But the agents would be basically small containers that have the agents inside that could be uploaded to an endpoint device, to a workstation, or to the data center, and they can all discover each other and communicate with each other.
Okay, and the thing about agents is it's not just an LLM, and large language model is not enough. So you have to have several layers to make agents work. And I was wondering if you could say a word about what is the most critical layer you are seeing in agentic, beside of obviously large language model.
Okay, it's a protocol what we used on your agent. We all know about MCP A2A for multi-agent architecture, but our reasoning, for example, but these things define the comportment of your agent, and in general, it will be define all treatment your agent will do. So it's a good example when you say you deployed a chip on Mars. You need to think about that before to be sure that your artificial intelligence don't use all the capacity of your chips. So that is really important.
For you, any?
Yeah, definitely. Like in our case, in coding specifically, one of the benefits that we have is that you're able to deploy the agents in a fully isolated environment. So these are, remote sandboxes, remote virtual machines that ideally can replicate as much as possible the real world scenario where it's going to be, having the code in production. So we optimize a lot the virtual environments where the agents are running to give them as much tools. So like the very easy level to be given to the agent is just a server that it can just execute things on. But some things that make it much more performing is that the moment it gets access to client, like different types of clients. So when you give it access to a browser, it can do the full client-side testing that, how did a web app load and end up for a user? Or if you do it with a client of a mobile device, it has the ability to do all these tests. So these environments are really critical for the agent. And this is one of the biggest pieces from a coding standpoint that beside the LLM optimizations that can happen, the entire environment, there's much more depth to be explored. There's way too many clients to be, given to the agent to really have full range of replica on what the real world looks like.
And I would say in general, in the physical world, an agent would be a small container that can communicate with a given protocol in a secure manner, like zero trust. No one should be trusted, even if it's inside a firewall, right? Zero trust communication, secured, and you can have an LLM. So part of the communication could be a prompt for an LLM, for example. But that's not the main thing in the agent.
Yeah, it can be subject with distant MCP approach. In fact,
one brief point to extend on this on the security side. One of the key things that we've been getting from users from our side and also internally is that all people now are really trusting these open source, like these closed source LLMs, just for the performance sake, just wanting to get the maximum performance. But the open source models are really becoming very good. And this pushed us to even dig even more deeper into that. And we've developed the first end-to-end encryption that is available with the agent that has access to, as a user, you are certain when you're using this coding agent as an open source model, not as a closed source. It is the first, and we're not aware of. We researched it intensively. There is no end-to-end encrypted agent that is now available in the market for large models. It is available for a single model that can be loaded on a single GPU, but security is a critical point, and we have a lot of customers that require the maximum level, and this is something that we wanted to make sure that it's developed and it's available.
Now I want to talk about something scary. How about benchmarking? How do you make sure when you're changing a part of a pipeline, everything is still working fine? And because it's really messy, we don't have any. It's not that easy when we are doing like regular ML. You just have some objective function. So it's quite easy to measure. But now, as things are getting messy, and especially with agents, how do you make sure your whole pipeline is working well?
Well, it's another question. At the beginning, we can think easily about a benchmark of LLMs or things like that. But what we said before, first of all, agents is not only about LLMs. But the better approach is to think about the context of the utilization of your artificial intelligence. Sorry. It's to be user-centric. You need to put your key metrics to define when you need to monitor the comportment of your artificial intelligence, and it's always depend of your utilization. And I think it's the most important thing. I don't have miraculous recipes for that.
Yeah, so there's very well-known public benchmarks that serve just for just some guidance. For instance, in coding, it's SW Bench Verified. There's SW Lancer, which was the most recent one that was released by OpenAI, which has a real monetary value per task. So these are all tasks that were made public on Upwork, but these are all real open source repos like Expensify, big repos, production level. So there's these ones that we track and we evaluate on. The other ones that are more impactful on our side is we've developed with the years that we've been working on the agent an internal coding benchmark that is also with the consent of users. When users decide to opt in, we get also to have some positive feedbacks from users. For instance, whenever a user decides to merge a certain code that was done by the coding agent, this merge is a successful performance. So we also get this insight from users, but it's definitely a continuous improvement. And scientific benchmarks are not sufficient. They're always not really reflecting the reality of the performance, but there's just a proxy on what you can expect. But we keep track of it on a continuous basis with our users and also with internally developed benchmarks to perform.
Okay, and we all know that it's using a lot of token to create agents. So maybe it will be LLM, but maybe not. I was wondering what is the biggest cost sink in AI pipeline, and maybe how it will evolve in the future. Maybe this one for you, Ramin?
Yeah, so in the data center, I think we all know what the cost sink is. So it's a rack, right? It's the GPUs, it's the networking, the SmartNIC, the switches, and so on. And you're right, with reasoning model, you actually have more tokens. You have more tokens that you can see because of the internal reasoning. And that costs a lot, but then again, generation after generation of GPU and networking, the cost drops. But then again, the reasoning goes up, so you have more and more token. I think the long-term solution is actually to move a lot of the workload at the edge and at the endpoint. Because if you look at your cell phone today, it's hundreds of thousands of times more powerful in terms of performance and performance per watt compared to the first Cray supercomputer in the 70s, the Cray 1, right? You're like probably hundreds of thousands of times more powerful in terms of performance per watt in your pocket at 4 watts than those mega flops at hundreds of thousands of watts in the 1970s. And this trend continues, so little edge devices or cell phones in 3, 4, 5 years will be as powerful as the most powerful GPU today in terms of performance per watt. And workloads will move more and more to the edge, and those will be super low power devices.
My last question. When agents takes real action, what are the most common failures you see? And what kind of guardrails you can put in place to make sure we can make sure it still works when those happen?
Like you just to clarify, you mean like how to make sure it's not going off track in terms of what you're defining it?
Yeah, because I mean a lot of things can happen during the execution. You can have a problem with your code. You can also have a problem with your API that is not responding, and you don't have any token. So how do you make sure it's still working? And maybe how can you recover? How can you have guardrails to make sure things are working smoothly?
Yeah, that's a really good point. So like on one side, like we've addressed this in multiple ways. One way is back to giving the control of the user on the user is deciding that does it have access to run terminal commands? So does it have access to modify all files, some certain files in the code? Does it have access to read some secret keys that these are private credentials for a company, so that they don't want to send it to any endpoint? So we can make this. We're addressing this in both ways. One is by access to these tools, so the agent has, there's no way for this agent to even get access to this tool whenever it's doing an execution. So we're restricting this tool access. The other aspect is that on the guardrail side is we've also integrated some parts where the agents, when it's much more in an autonomous mode, we've allowed the agents to trigger SMS and phone calls and Slack notifications to the human, saying that it's hitting a certain problem, and then it requires an intervention from a human. So this is just for purpose of it's not able to complete its task, so it's stuck at some point. So it will wait until there's a human intervention and then allow it to proceed even further. So we've initiated those with very exciting integrations. On the voice side, it's actually triggering a full phone call to the human, having a full conversation with the context of, let's say, a running server log or a running task that is currently ongoing. So with full natural voice, with collaboration with 11 Labs, so we're able to get an experience that is, very much like a teammate engineer that is working with you, but having the full context on what's the task at hand and the code base that it's working on. So these are some of the things that we're looking at.
UX again, Benjamin?
Well, for an agent, when you work with users, you work with chaos. So, of course, you can work on your retry system and you can protect everything. But at the end, you should give all information to your users to take more information to retry something. It's your last solution, I think. And the most important thing is to give to these users all things to monitor what is going wrong. So, yeah.
So thank you all. We're closing this panel. So I think we now have a clear picture of how agents work today, what still block them, and what these shifts matter. Agents can live in cloud system, on the edge, even in factories. They change workflow, they change how we think about UX, about code, and we will see why they need guardrails. So thank you again, Benjamin, Robert, Ramin, and enjoy the rest of AI Pulse, and see you around.
Thank you. Thank you.